So this is from A-level geometric sequences. This is A2 pure maths. The term of a geometric progression are given as U1 to U5, and this is geometric progression. Given that U4 is equals to 6, U3 plus U5 is equals to 20, show that, so we have a quadratic expression that we need to get in terms of R, where R is our common ratio for the progression. Okay, so any geometric terms start with, so the first term U1 will be A, U2 will be A times some common ratio R, and then U3 will be A times R squared. So every term you're just multiplying by an R. And U4 is going to be R cubed. U5 is going to be R to the power of 4. So the question has given us that U4 is 6. So this term over here, that's equals to 6. So let's write that down. So AR cubed is equals to 6. And they've also said that U3 plus U5 is equals to 20. So U3 plus U5 are these two terms, U3 and U5. So what we're going to write here is AR squared plus AR to the power of 4 is equals to 20. So let's simplify that a little bit. So AR squared is a common term. You can take that out. What you're going to end up in the bracket is 1 plus R squared is equals to 20. What we have here is two sets of equations for A and R, and we need to get a quadratic in terms of R. So we need to somehow eliminate A and simplify for R. So what we're going to do is we're going to take the second equation and divide it by the first one. That's the only way we can divide by A and then cancel each other out. So let's write that down here. So AR squared into 1 plus R squared over AR cubed is equals to 20 over 6. Let's simplify everything. So A cancels out here. R squared cancels with R cubed here, so you're going to end up with R. That also cancels out to 10, sorry, not 100, 10 and 3 here. Okay, if we rewrite this, we're going to end up with 1 plus R squared over R is equals to 10 over 3. Okay, cross multiply it, you're going to end up with 3 into 1 plus R squared is equals to 10R. Expand the bracket, rearrange, obviously keep your 3R squared positive there. So 3 plus 3R squared is equals to 10R. Therefore, your final answer is 3R squared minus 10R plus 3 is equals to 0. That's the show that part of the question done. So part B, it says given further that the progression has a sum to infinity, so sum to infinity, determine its value. So if you look at the box here, what I've given you is the formula from sum to infinity or geometric series from the A-level Edexcel formula booklet. Okay, so the terms that we need are A and R. So sum to infinity is sum to infinity is equals to A over 1 minus R. So you need to know the values of A and R, then you can plug it in and calculate this. Okay, we have a quadratic in terms of R, so let's figure out what our R is going to be. So this is part B. So 3R squared minus 10R plus 3 is equals to 0. So if you factorize the term, you have 3R minus 1 into R minus 3 is equals to 0. So R here is either a third or R is 3. Now, for a sum of geometric series to add up to, you want to add all the terms up to infinity, you want the term to converge to something. So you want it to get smaller and smaller as you're progressing. So R3, that's not going to happen. It's going to diverge. So a condition for a sum to infinity, the modulus of R must be less than 1. That means this is the term that's less than 1. This is not our r. You have to choose one or the other here. So r has to be a third. That's the condition for us to have a sum to infinity for geometric progression. So we've got r here. We need to calculate the value of a. So we have an equation here that we can use where you can plug in for r and you can rearrange to find a. So let's do that. So I'm going to take from here. So a r cubed is equals to 6. So a into 1 over 3, so a third cubed is equals to 6. So that's going to be a is equals to 6 times 27, which is 162. Okay, so that's your a, and this is your r. So all we have to now do is plug it into the formula and calculate the answer. So let's do that. So sum to infinity is 162 divided by 1 minus a third. So that's going to be 162 divided by 2/3, and the answer is 243. Okay, that's the sum to infinity for this geometric series. Thank you for watching.